what do those measures of position mean? Position of what? A point in the data or in the sample. So, but in what way? Of course, it is the position of an observation, but in what way are we looking for that position? So, what is of importance? If you're running a marathon or a race and you consider yourself your observation and you get a position, right? Yes, but the position compared to what? Time, but how do we determine your position? Point A to point B, okay. Distance, okay. Thank you. What's your name? Hannah. Hannah says other people, right? If I'm going to rank you, of course, time is needed, distance is needed. But if I don't have a bunch of people running with you, I can't put you in a position. So when we say measure of position or measures of position, we are talking about an observation relative to every other observation. Position of observation relative to every other observation of the sample. They are called percentiles, and notation-wise, PK would mean kth percentile. If an observation is P10, in other words, 10th percentile, then 10% of the observations in the sample will lie below P10. So if I called some observation to be P10, then 10% of the observations in the sample must lie below that number, P10. Let's say I call a number as P30, then what would it mean?
30% of the data would lie below?
30% of the data would lie below P30. If I said P80, 80% would lie below P80. Okay. I hope you guys remember measures of center. You should remember if you did the homework. What are, well, let me ask this question. We have already seen one measure of center that is a measure of position, or that is also a measure of position. Which one is it? Who said it? Why?
Because it's in the middle of the data.
Your name is middle of the data?
Sorry?
Your name is?
Oh, Samantha. I thought you said
Samantha, go
why.
ahead.
They said why.
No, why, go ahead, Samantha.
Oh, because it's in the middle compared to all the other.
Right, because a median would split the data exactly in half, right? Half on this side, half on that side. So the measure of center, that is also a measure of position, is the median. That said, what percent would lie below the median? 50%, right? So can I write the median as P sub 50? if I cut the lower half of the data exactly in half, which is probably there, what should I call that? A25. If I cut the upper half of the data right in the middle, what would I call that? P75, because 75% of observations would lie below P75. Well, now that we've established that, what is the minimum if I have to represent it as a percentile? P0. Nothing lies below the minimum. What about maximum? P100. Everything lies below maximum. Does that make sense? Okay. This is great and all. If you ask me, well, I'd go for very accurate percentiles. In the sense, I would go for, even if it is 62.19, to me, it is the 62nd 0.19th percentile. That's how I would want to interpret it, because I like accuracy. But I can't take that information and give it to the general population, because not everyone understands math or stats really well. So we simply give the values at 0, 25, 50, 75, 100. And more specifically, since these happen every quarter, we call them Go ahead. Quartiles. So first quartile, second quartile, third quartile. The distance between the third and the first is called the interquartile range. The interquartile range is a measure of variation, just like the standard deviation, but this is just more accurate because it involves percentiles. In practice, there are other ways to assess percentiles. Some people like to measure them at every tenth. So P10, P20, P30, all the way up to P100 are deciles. Just a fancy name. So if you see a decile somewhere, this is what we mean. We're measuring percentiles at every 10 or every 10. So P10, P20, P30, and so on. And then there are quintiles, which would be at every 5 and so forth. But once again, I like that because it's more accurate. You don't have to worry about that in this class. Good. Good thing. Now we want to know the percentile of an observation. So consider an observation X in the sample, then its percentile in other words, the observation's position in the sample is calculated using this simple formula. We just count the number of observations below X in the sample divided by the total number of observations, in other words, the sample size, multiplied by 100 to get it as a percentage. Does that make sense? So This is one of many ways to determine percentile of an observation. I'm sticking with this because the book is using this. But there are multiple corrections that we can do in getting the percentile of an observation. Are we clear? So we simply have to count the number of observations below X and divide it by the sample size. Good? With me? In order to construct a Box-Whisker plot, we need 5 numbers. Good. And all of those 5 numbers are measures of position. If I asked you to guess those 5 numbers, what would they be?
Quartile 1, quartile 3, and then
Exactly. So the first number, minimum, right there, quartile 1, there, quartile 2, quartile 3, maximum. Good. That's what I call the 5-number summary. Very creative because it has 5 numbers. There are advantages to having a Box-Whisker plot because people can interpret it easily. So business people can use it, people in social sciences can use it. A histogram, on the other hand, requires some additional knowledge, but a Box-Whisker plot is easier to interpret. It has the ability to give us information that we can't get from a histogram. So I'm going to draw a bunch of cases. With my poor artistic talent, I want you to draw these. You should understand the creativity behind naming a Box-Whisker plot by now. Yes? Why do we call it a Box-Whisker plot?
so it's a box. and
Because there's a box and
Whiskers.
2 whiskers on either side, one on either side. Hence the name Box-Whisker plot. If I asked you, well, of the 3, which one, these come from 3 different samples. And if I asked you, out of these 3, one of them doesn't have a lot of skew, pick that one. Which one would you pick? The first one. Why? Even. We use a fancy word to say even. Starts with S. Twice. Symmetric. So symmetric whiskers. Symmetric or balanced. If you see asymmetry or if you have unbalanced whiskers, definitely have skew. Would we consider number 2 and number 3 to be unbalanced? Yes. Would we think that they have skew? Yes. If so, what type of skew does the second one have?
So the two little parts are towards the right, which is basically just have to go.
Skew to the right. What's your name? Ralph? Alfie? Matthew, okay. Okay, so I gave you 2 new names. Right, Matthew says this is the length is, this way. He even sort of gave a diagram for us, something like that. This is what he showed. And he said it's right skew. Do we agree with it? We agree with it. Why? Oh, it's skewed to the right.
Oh, wait, never mind.
Yeah, I know.
You can't say never mind, it's skewed to the left, I'll try it right. So the pole is on the left-hand side, so this is left skew. The other one is right skew, so that's something like that. So this curve is, the relative frequency polygon or density that we get from a frequency histogram. So they are very equivalent. That's why I mentioned earlier that whatever information that we can get from a histogram can also be obtained using Box-Whisker plots. And it is a matter of choice as to which one to use. If I asked you, out of the 3, which sample has the greatest variation, which one would you say?
2 or 3, depends.
2 or 3 depends. Someone said 1.
The third one?
The third one?
Yeah.
Do you think 1 has a lot of variation compared to the other 2? No. The greatest variation is between these 2. So based on your perception, it could be either 2 or 3, but I would say both of them have greater variation compared to the first one. Does that make sense? How do we determine, or how did you get to that, conclusion that they have greater variation compared to the first one? What gave it away? That's true. What does this mean?
It's asymmetric.
It's asymmetric, okay.
It's not symmetric.
Right. What else?
I'd say the range on that would be like, I'd say there are outliers from the right skew like that. There's more like potential outliers to the right. Therefore, the range between everything is larger. So there's more variation in that case.
Good. So there's a wider range. In other words, we combine the whisker lengths. The whisker lengths are pretty long. So the longer whisker lengths you have, the more imbalance you see, chances are you are going to end up having greater variation. Does that make sense? But you can only do this when you compare different box plots. You can't simply look at one single box plot and say, oh, that has a lot of variation. But what if the minimum and maximum are wide apart, but they are fully balanced, right? So when we compare box plots, we can identify variation. Any questions? Are we clear? Okay. And what's work really, really hard. So, I have entered the data in the calculator, list one. Now, press start. Go to help, over. Select one. The newer version of the calculator would have fields or fields list one, break and calculate. This is the older version, so simply second one. This is because the data is in list one. Hit enter. What is the first number? Yes, I know it is 4.107, but what is it?
Oh, you mean the min bar?
The mean.
Oh,
Right.
the min.
What is the fourth one?
2.3.
Standard deviation of
The same.
the samples. What is the fifth line?
The population.
It is the population standard deviation. As far as this class is concerned, which one are we going to use more frequently? What?
Sample.
Sample standard deviation. So line 4 and line 1, very, very important. So we have 28 observations. Minimum, that's one. First quartile, median, Q3, third quartile, and maximum. So we have all the 5 numbers that we need to do the Box-Whisker plot. Okay, so learn how to use the calculator. I heard someone actually tried to do variance by hand. Good for them. Moving on. So we want to graph the Box-Whisker plot. This will give a good idea when you do my math lab to get a picture. So we have to go to the start plot. So second y equals. Now mine is already on, so 1. If yours is not on, switch it over using your arrow key, turn it on. We have 6 options. Yes. Yes. Are you guys looking over here?
Yes, sir.
Okay. So we have 6 options. We have used one already. That would be the histogram. In the second line, there are 2 options. Both of them are Box-Whisker plots. The difference being the first one is going to show you the outliers as dots. The second one is not going to show you the outliers. Does that make sense? Okay, I'm going to start with the second one. But before we proceed, we have the mean. The mean was 4.107, around 4. What was the median? I believe it was 3. So do you expect to see some sort of skew?
A little, not a lot,
A little, not a lot. Why, Nick?
because the median and the mean aren't exactly the same.
Because the mean and the median aren't very close to each other. They are, far apart, at least by 1 unit. So there is a good possibility that this particular data set has some skew. It's not going to be symmetric. So go to option 5, enter. Option 5 in the sense, the 5th picture that you see, icon. Row 2, second graph, and that is the Box-Whisker plot. Did we get it? It's not working.
I'm pressing enter.
So I want you to give the mean of the mean, Q2, Q1, Q3, max and min. For the data that we just used. The number of hours spent studying. What is the minimum? What?
One.
1. This is 3. What is Q1? 2.
2.
Q3?
6.5.
Maximum?
8.
8. Good. Now, we know that this is P0, P25, P50, P75, P100. Yes? No. If I asked you, so my question to you is, what is the percentile corresponding to 7 hours? I just want you to guess or agree with me or disagree with me as I throw a bunch of percentiles to you. So I want to know the percentile corresponding to 7 hours. My first answer is P10. Could it be P10? Yes or no? No. Could it be P40?
No.
Could it be P62?
No.
Could it be P99?
Yes. Maybe, probably not.
Maybe, right? Could it be P80?
Sure.
Yes.
More likely. Now, how did we assess this? What gave it away? Very good. So 7 hours, probably somewhere over there, right? Maybe over here, that artistry, 7. Right. If that observation is between the 75th percentile and the 100th percentile, this must have a percentile between those two values. Yes? You have the data, let's pull it up there too. I want you to find the percentile using the formula that I wrote at the very beginning. Count the number of observations below 7, divide by the sample size, and tell me what you get. So there are 21 observations that lie below 21. Yes. How many observations do we have in total? 20. So the number of observations below 7 in our data, 21. Total number of observations, the sample size, is 28. Divide and multiply by 100%. What do we get? 75. Now, so I'm going to say that the 7 hours is also P75, right? The reason why this happened is because there are a lot of 7s in the data, and those are very close to the 6.5 that we have. Had I gotten, had I put this as 6.75 or even 8, I might get, a value close to P75. So our initial guess was, could be perhaps P80. But because of the nature of the data, we landed at P75. But still, it's somewhere here. Yes? So when you do a problem like this, understand it prior to even putting the answer in. Are we clear?
Yes.
Okay.